Bulbs, ammeters, ammeter, bulbs, parallel circuit because we've got two loops in our circuit, and then this is a series circuit because we've only got one loop. I'm going to write down the rules and then I'll explain them one by one. In a parallel circuit, I total is equal to I1 plus I2 dot dot dot. V total is the same everywhere, equals V1 equals V2, and the total resistance is actually the reciprocal, so it's 1 over R total equals 1 over R1 plus 1 over R2. Okay, so that's for my parallel circuit. For my my series circuit, this one here, I total equals I1 equals I2, V total equals V1 plus V2, and R total equals R1 plus R2 dot 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 dot. What does that mean? I stands for current, right? V stands for voltage or potential difference. R stands for resistance. So, in a parallel circuit, the total current, which we measured up here, will be equal to the total current which we measured up there will be equal to the current here and the current there. If I was to draw that bigger, here's my parallel circuit, and if I had a current of, let's say, 2 amps up here, 2 amps up here, and I had a current of 1.5 amps in this branch, how many amps would I have in this branch? I'd have this plus this to equal to that, so I'd have to fill in the missing number, so 0.5 amps. Only in a parallel circuit. At this junction here, we say that it's conserved. So the keyword you need for that, conserved. Which means I'll have 2 amps there, I'll have 2 amps there, I'll have 1.5 amps on this branch, I'll have 0.5 amps on this branch. If I was to look in a series circuit, with a couple of bulbs thrown in for good measure, if there's 1.2 amps here, there will be 1.2 amps here. The current stays the same in a series circuit. Voltage, however, if I've got 6 volts coming off of my power pack, I will have 6 volts on this bulb and 6 volts on this bulb. The potential difference is the same in whatever branch you look at. In a series circuit, if I have 6 volts coming off of my power pack, and there's 4 volts here, there'll be 2 volts there, because the voltage is shared among the components. So have a look at current. Current is conserved in a parallel circuit. That means that the branches must add up to the total current. In a series circuit, the current is the same no matter where you are in the circuit. The voltage is the same in every component in a parallel circuit, and the voltage is shared across components in a series circuit. So I total equals I1 plus I2 in a parallel circuit, right? Total current is equal to this branch plus this branch. In a series circuit, I total equals I1 equals I2. The current at any point on this circuit will be the same. V total equals V1 equals V2. If this is 6 volts, this will be 6 volts and that will be 6 volts. V total equals V1 plus V2. If this is 6 volts and this is 4 volts, this must be 2 volts, because the current, the voltage is shared amongst the components. For the resistance then, I'm going to draw a parallel circuit that has got plus minus a couple of fixed resistors in it. Say that this is 5 ohms and that this is 10 ohms. In a parallel circuit, the resistance is always smaller than the smallest resistor. Okay, and the reason for that is to find the total resistance. It's 1 over 5 plus 1 over 10. So if I was to do that like this, 1 over R total equals 2 over 10 plus 1 over 10. So it's equal to 3 over 10. So 1 over R total equals 0.3 ohms. I can then flip that over and it becomes 1 over 0.3, whatever that is. So R total over 1 equals 1 over 0.3. If that was a series circuit, 5 ohms, 10 ohms, R total equals R1 plus R2. So your total resistance would be 15 ohms. Okay? So in a series circuit, the resistance is additive, it all adds up together. In a parallel circuit, the resistance actually decreases the more resistors you put in. Why that happens, I don't really know. I keep on asking people and they can't explain it. If Mr. Patrick was here, he might be able to do it. I don't understand it, I just know the rule. Oh, Mr. Patrick is here. I won't ask him to explain it. So, right, that's it. That's a series and parallel circuit rules. The other thing is, if you're looking at a circuit, and they're asking you to figure out any aspect of resistance or current or voltage, V or I or R, how can you find the resistance out from a circuit diagram like this? Well, you've got the voltage, so let's say it's 2 volts, and the current is 1.1 amps, and it's asking you to find the resistance. You can use an ohmmeter, but I've never seen that talked about before in a guide or anything like that. Usually what we do is we measure the voltage and the current and then find the resistance using Ohm's law. And we rearrange that to find resistance. So it'll be 2 over 1.1. Whatever that works out to will be your resistance. Okay, so quick recap. Parallel, series. V total. The voltage is the same no matter where you go in a parallel circuit. In a series circuit, the voltage is additive. The voltage is shared. The current in a parallel circuit, you have to add up all the branches to get the total current in the circuit. In a series circuit, the current is the same everywhere. Resistance 1 over R total equals 1 over R1 plus 1 over R2. In a parallel circuit, the resistance will be always smaller than the smallest resistor, and the resistance in a series circuit is additive.